Okay, I think we'll get started. So it's been a little while with this series. Back to it for a little bit here. The next lab is not really a lab per se. It's really figuring out how to go through the different internal clock speeds for the PIC12F1822. It can run as fast as 32 megahertz, but it's a little confusing, and so worth running through. It'll help us think about the configuration bits, which we usually just copy and never deal with again, and the OSCCON register. So we'll work through that a little bit and kind of see how we can control the clock speed on this PIC. All right, let's go to the computer. And so the setup here is very simple. Just have the PIC right here, and then just an LED to show. We'll just blink an LED, and it'll just change with the clock speed of the PIC. So we won't change the code, we'll just change the clock speed, and we'll get a sense of that change here. And then this resistor is just going to ground so that we're not running the LED all the way to ground. So this is just blinking, and so like the earlier lab, but now we're going to change the clock speed. So let's go ahead and open up MP Lab here, and I always just close the start page, and we're going to want to start a new project. So we'll go to File, New Project, and just microchip embedded. Next, I've been using this, so recently used, and we'll go with the PIC1822, and we will use the PIC5. So we've got the PIC5 here. And we can skip none here. We'll want to do assembly, so we'll pick the assembler. So right here, the assembler. And project name here, let's just call this FOS test 1. And we'll finish. Okay, so little setup here once this gets going. It's like it might be hung up a little. Sometimes it's been doing that on me lately. Whoop. All right, I'll relaunch and start again. I'll pause the video and come back. Okay, sorry about that. I've been very frustrated with this Linux on this particular machine. Crashes very often. So we've got this set up now. So what we want to do is get a new source file, assembly file, and we'll just call that main, and it'll be main.s, and we'll finish. I'm going to get rid of this start page again. Okay, so we've got blank code. We're going to do just one real quick thing here. We'll want to, this is a very simple circuit, so we'll just power it with the PIC. So we'll go to settings over here and choose over here, we'll choose the PIC5, and then we'll go up in here and choose power, and we'll power voltage level 5 volts. This is a 5 volt PIC here. So we'll apply that. Okay, now instead of typing everything in, we'll just go to my GitHub page. So almost here, we can go to the one for this project, and we're just going to take this test, and I'll just copy that, and we'll go back here. Okay, just want to do a quick build and run, make sure everything copied. Okay, so I'm going to build here. Build was successful, so we're going to run. We're going to get an error or a warning here about the voltage, and we'll let that go, and then we'll just say that's okay, because it's just trying to save your device, and this is 5 volts is fine. Okay, complete, and we're blinking here. So we've got the blinking program going, and now we're going to get into these configuration bits a little bit. So first thing we're going to do is we usually have this on this 4x timing, the timing amplifier, or amplifies the clock time. But we're going to turn this to off for now. And then we're going to keep this off. We'll turn it back on in just a bit, but we'll turn this off. And what we want to do here is refer to page 65 in the data sheet. So I'm going to minimize this now. I've got the data sheet up here, page 65. So this is the key page here. We're working with the OSCCON. So we've moved to bank 1 where the OSCCON is. So we go bank cell, that gets us to the right bank, over to OSCCON. Then we just clear it for good measure, and now we're going to set it. And we're going to set it according to what we want over here. So let's really understand the bits here now. So these two bits here, bit 0 and bit 1, are going to choose whether we are going to use the FOC here, and that will be governed by our word up here. So it says word 1, so that's up in here, and so that means we're going to be using this guy. If we go with a 1 anything, so usually I just put a 1 1. So if I were to put that with 1 1 here, then it would be bypassing whatever's going on here. So it would not be using the FOC. Okay, so we're going to let's use the FOC here. So I'll go 0 0. Now we can read this chart here, and what we've got here set is the maximum clock speed that we can get without the 4x enabler. So the 4 next bits here are going to tell us which which speed we're using here. And so we can see here 1111, that's 16 megahertz. Now notice that's not 32, it's not the maximum speed of this chip, but it's the maximum speed here with this internal oscillator without the speed amplifier, the PLL, feedback loop, I think. Okay, and then finally, this turns that on or off, the 4x or off. So we're going to have it off for now, and so this should run then, based on this should run at 16 megahertz. So that's what it is. Now let's do something to change that and see the change here. So I'm going to step this down to 1 1 1 1 1. Let's go 1 1 1 0 1. So this is going to be 4 megahertz. So it should go 4 times slower here. So the period should be 4 times longer. So let's go ahead and build that. But I don't want to show this again. Okay. And now we're going to see a much slower time scale. So blink, no blink here. Right. So now our timing is 4 megahertz. So you may want this. In fact, I think on one of the earlier videos we did have it at 4 megahertz because we were trying to match something we had done with one of the smaller PICs, the PIC200 or something. Okay. So let's change it quickly here. Let's go back to 8, just to get a feel for things. So we'll go 1 0. That's going to be 8. Now, is it going to be 8 or 32? So let's check that. It'll be 8 here. So we'll go twice as fast as this, but not as fast as the first one we were seeing. So we'll go ahead and so we're speeding up our frequency here a little bit, right? And then if we go back to 16, so this is 16, so this should be faster, right? So let's go ahead and run that, and now we're blinking a little bit faster. Okay, but we're not blinking at the 32. So let's try to do the 32 with this setting. So it says here we have to go back to the 8 mode, and let's try putting the 4x on and see what happens here. And we indeed turned it on, and now we are at full speed. We're at 32 megahertz. So that is one way to do this. So that's one way to control this. Probably more than enough, more than what you'll need. But let's look at how to do it up here with the configuration bits and by turning the FOC on. So I'm going to go back over here and oh, sorry, this the FOC is on here. Let's try to do this now with just the internal block and see what happens. So I'm going to turn the FOC off here. I'm going to go to the internal block here, and let's see what we get. See, we're back, even though we have this on, it's 1 here, we're back to the 8. Because if we go 16 here, this will go faster. This should go faster. Right? And whether I turn this to 0 or a 1, I get the same speed here. And then if I go back to the 8, and I will turn this back on. So it feels like this should go at 32, but it's just going at 8. So we really do need this FOC on, and so let's turn that to 0, 0, and let's turn this off here now. And so we saw how that all worked with turning the 4x on. Well, I'll go ahead and turn it on here, and this should be back to 32 here. Okay. So we could control that to 8 to 32 when that's on. So we can hit all of those. But now let's go up to the configuration bits. This is what I was trying to get at earlier. So let's leave that on like we normally have it. And let's see what happens. In this here, we do expect now to get a 16, right? 32. So let's give that a try. And there we are, 32. Now, let's see if we can make it do an 8. So I'm going to go over here. I'm going to change this to a 0. And remember, that was giving us 8 before. But notice it isn't this time. So when this is on in the configuration bits, we are locked into the 32 and we cannot get the 8. So that's one thing to know, I guess, about turning that guy on. And there is a warning up here. Let's see, I think it's, let me go to this, and then it's just down a few pages. So right here, when using the PLL 4x in the configuration word 2, so that's over here, the 8 megahertz is disabled. So that can be a little confusing if you're trying to get the 8, and it's like it seems like you have it set for 8, and it's giving you the full 32. All right, so that's kind of a little bit about the speed, the controlling the clock speed on this. Good to know, I think. Many times it doesn't really matter, and for most of the stuff it doesn't. We're going to be actually going into a segment here using the phase pulse width modulation, and you do kind of want to change the clock speeds, because that'll help you control the frequency of the pulse width modulation. So this PIC has a peripheral pulse width modulator that'll just run without the central computer part of it. So it'd be different, a little bit different than bit banging on off on off on off. This will just run kind of independently of that based on the internal timers, and this clock speed controls that internal timer. So it does become important at times. All right, that's it for this video.